In this video, we're going to find the area of parallelograms. This is for geometry, homework 101. All right, so when we find the area of a parallelogram, it's very similar to finding the area of a rectangle. We take the base times the height. So A equals BH, and this is because we look at this area right here. If we could move that right over here, we actually would get we would actually get the same exact area there, and we would end up like with a rectangle. So that's how this kind of works, is if we cut off this little triangle over on this side and split it around right there, it's the same amount of area we would have as if we had a rectangle. Okay. So let's get back to solving this one. If we have base times height, our height is always the height of the parallelogram, which is the perpendicular segment there, and then the base is the length across the base. So when we're finding the area on this one, we would take our base, which is 3 squared of 5, multiply by the height, which is 2 squared of 2. And when we do this, we multiply those two, the outside 6, and then we multiply the 2 square roots, squared of 10. And we cannot reduce 6 squared of 10, so our area is 6 squared of 10 units squared. Let's talk about one where it doesn't give us the height of the triangle, of the parallelogram. So we want to draw a line in for height. This is a right triangle here. And we know that this length has got to be 10, the same as this side over here, because this is a parallelogram, and by definition that is true. If this is a 30, 60, 90 triangle, which it looks like it is, we need to find the long leg of this. And we know that our formula for 30, 60, 90, we've got x, 2x, and x squared of 3 right there. So our next step is to find x. If 10 is equal to 2x, then x must equal 5. And this length right here must be 5 squared of 3. If you have questions on that, you can go find my video on solving these. Now we need to take our base times our height to find our area. So here's our height, and here's our base. A equals BH also equals 15 times 5 square root of 3. 15 times 5 is 75. Bring the square root of 3 down. Units squared, that's our answer there. The last one we have is if this is not a typical 30, 60, 90 triangle that we might draw in here. In fact, this is not a 45, 45, 90 either because of this 115 degree angle right in here. So we need to decide how we're going to solve for this. And I'm going to rewrite this 13 on this side. And the next thing we need to do is figure out what this angle is right here, because this little angle that we just created is not 115 degrees. And this other angle that I just marked out here is also not 115 degrees. But we do know something about parallelograms, that the two angles right there total 180 degrees. That means that this small angle down here must equal 65 degrees. So since we have a side length of a triangle, the 13, and we have the angle measure, there's a side length and an angle measure, we can use some trig to solve this one. Looking at our SOHCAHTOA rule, we need the opposite side from our angle, opposite side. So that means it looks like we'll be using sine. So sine of 65 degrees equals the opposite over the hypotenuse. And now we need to solve. And doing that, we multiply by 13 on both sides. Those cancel out to 1. We plug this in our calculator, and we end up with our opposite side equaling 11.8. 11.8, and then we can find the area of our parallelogram using our formula A equals base times height. Our base is 17 square root of 2, and our height is 11.8. 17 times 11.8 is 200.6. We multiply this by the square root of 2 and add our units squared, and that is our answer right there. If you have any questions, please make sure that you contact me.